So in this video, we're going to practice finding derivative functions using the product rule. So at this point, we've talked about finding derivative functions. We've talked about if we're adding or subtracting functions together, how we can take the derivatives individually. And at this point, we're just trying to build more functions using our small building blocks to see if we can find more derivatives of more complex functions. So we're going to be using the product rule in this case. The product rule for derivatives. And this is assuming that if f and g are two differentiable functions, then when we take the derivative of the product of those two functions, that this will be equivalent to taking the derivative of the first function times the second, and then adding the derivative of the second function and multiplying it by the first. So the hardest challenge with these kinds of problems is kind of visualizing how we can define f and g before we even get to the algorithm. So I like to imagine myself as like a ceramicist. Like before I even create like my clay pot, I have to visualize what I want it to look like, and then I can act on it. So in this case, we have two quantities, and I'm going to say, let this define f of x. So 2x plus 3, and then I'll have g of x. Okay, so now that I've defined my functions, I have the correct setup for this product rule. The derivative of the quantity 2x plus 3 times the quantity negative x plus 4 can be calculated by taking the derivative of 2x plus 3 times negative x plus 4. And remember, just using like order of operations, this derivative is just being applied to 2x plus 3. It's not being applied to this negative x plus 4. And then I'm going to add the derivative of negative x plus 4 and then multiply that by 2x plus 3. So at this point, we should know that taking the derivative of a quantity 2x plus 3 means we can take the individual derivative. So the derivative of 2x would just be 2, and the derivative of 3 is a constant function, so it will be 0. So I'll just have 2 times negative x plus 4. And then the derivative of negative x is going to be negative 1. And the derivative of 4 will also be 0. So this will just be negative 1 times the quantity 2x plus 3. So at this point, the only thing left for me to do is to simplify and combine like terms. So I have 2 times negative x is negative 2x plus 8, and then plus negative 2x, which is the same as subtract 2x, and then minus 3. Combining these two things, I will have negative 4x, and then plus 5 is the derivative function, of 2x plus 3 times negative x plus 4. And just to double check my work, I'd like to distribute these out so we have a function that's written just in terms of pluses and minuses, and then we can take the derivative that way. So note, let's check. 2x plus 3 times negative x plus 4 is equivalent to negative 2x squared, negative 2x squared plus 8x minus 3x, and then plus 12. So if I take the derivative of this function, negative 2x squared plus 8x, and actually let's combine this 8x and minus 3x to be 5x. So we have plus 5x and then plus 12 gives me the individual derivatives negative 2x squared plus the derivative of 5x plus the derivative of 12. And this will indeed give me negative 4x plus 5. So just as how multiplication of real numbers can help expedite the process of repeated addition, using the product rule can help us expedite the process of finding derivatives of more complex functions.